In this video, we'll focus in on data visualization, best practices, and understand how good visualizations they optimize for the way we see things, the way the human visual system works. Now, the points covered here, they come from the work of a number of influential authors, including William Cleveland or Bill Cleveland here in this book, Edward Tufte, of course, and more recently Kieran Healy. Now, all of these books are seminal works in their field and they're worth reading. However, only this last one is available online for free, and it comes with all the R code to generate every figure in this book. So check it out at this link. Now, synthesizing all this work of these authors and several others, the key point that I want to emphasize here is that good visualizations optimize for the way we see things, for the way the human visual system works and perceives differences. So this might seem like common sense, but particularly from the work of Bill Cleveland, we have a formal set of guidelines, if you will, where we can rank and prioritize how we display the most important measurements in our data set. We can build on the kind of hard-earned experience of these authors and these researchers in the field to make our plots better. So that is the thing that we want in our data that we care about most should be higher up in this list. It should exploit the highest ranked encoding here, as Bill would talk about in his book, from this ordered list. Another way to put this is the higher up we are in this list, the happier our visualizations, and in turn our viewers, our readers, will be with our visualizations. So let's start at the bottom here with color and work our way up. Now, color, perhaps surprisingly, it's a rather complicated thing. It's composed of a combination of three things here, at least: hue and saturations and luminance. Now, hue is like the spectrum of colors that we would commonly use, color names for, like the red, the orange, the yellow, green, blue, purple, etc. It's the frequency, if you will. Color saturation, it refers to the intensity of a color in an image, like how much of that color there is in essence. In technical terms, it's actually an expression of the bandwidth from a light source. And then luminance, of course, it's the perceived brightness of color. So taking color, this complicated thing here, and putting it in as the main aesthetic, the main way to display the data that I'm interested in. So in this case, it's actually fuel efficiency measured in miles per gallon for some old cars from 1970s America. Now, this is an inbuilt data set. Where I'm getting this from is from R. It's called MT Cars, and we'll play with it a little bit later in our hands-on session. But for now, we're displaying this as a kind of like a heat map, right? We plot these things in bioinformatics all the time. We use them where it might be, gene expression, for example, rather than cars. It would be genes and the amount of them present in a given sample, for example. So here we have miles per gallon, and I can look at this and see that these two cars, right, a Pontiac Firebird, that's a car that I only ever saw as a little Matchbox model and thought was the coolest thing ever because it had a big eagle in the bonnet, right, a muscle car. It's more fuel efficient, surprisingly, than this Mercedes, a boring, more sensible German car. And we can see that because they're right beside each other and their colors are different. I can look across to the legend here and see that one color, the Pontiac Firebird, indicates that it's more miles per gallon than the Mercedes in this case. Now, if I had to go and compare something a little bit further down the plot, something more removed, like here I'm going to compare a Dodge Challenger, another cool car, right, a muscle car, to that Mercedes, it's kind of challenging to do this because they're separated here. Right? It's kind of difficult to see, is there any difference? Looking across to the color scale and back and forth, I can't really tell in this case. So now, if we were to compare, for example, a Chrysler Imperial, like a big tank of a thing, compared to, for example, a Toyota Corolla here towards the top of the list, we can still see that there's a difference because their colors are so strikingly different here. And now we could have, of course, probably figured that out from our domain knowledge, that a Toyota Corolla will be more fuel efficient than this huge, heavy Chrysler. But the fact remains that if we didn't know anything about cars, if we didn't have that domain knowledge, like if these were genes, for example, we'd be asking our reader to do a lot of work. We'd be asking them to stare at different regions of this plot, go back and forth to the legend and compare, and then maybe back to the legend again before they figure out what could be going on here to see if there actually are clearly different. So the key observation here that I'm trying to stress is that ordering matters. The way we have those things ordered along down that axis matters. If this plot was arranged, it's arranged just like the data is, alphabetically by car name, just like we get the data. It's never the correct ordering of a categorical variable. So in this case, if I take it and I order it instead by the value I'm actually interested in, so the miles per gallon here, we can improve this plot quite a bit. That's because the order now along this y-axis here, along the vertical axis, actually tells us something about the miles per gallon ranking or rating, if you will. Right? So the higher up you are, the more fuel efficient you are, and we can tell something about just your position in the plot. However, there's still big limitations here. For quite a few of these cars, for example, these ones highlighted here with the red line, I still could not tell if there's much of a difference. Is there any real gain in getting the Chrysler versus a Maserati in terms of miles per gallon? Okay. So another important limitation that I want to highlight here is that if I took the legend away and showed this to someone with no domain level knowledge, didn't know anything about cars, how would they know that the things higher up are better miles per gallon? Is there anything intrinsically linked between orange and low fuel efficiency or low fuel consumption and miles per gallon? No, of course not. There's nothing linked between these things. So rather, I should use different saturation values of a single color or hue here. Then, if I have more of the color, I'll have more of the numeric thing that I'm actually plotting. In this case, it's miles per gallon. So here we're being kinder to our viewer and not requiring them to do so much work, right? I'm taking that trend and showing it as a single color that's changing here in saturation, and they're not going to have to do as much work. More of the color means more of the numeric value that I'm actually trying to plot, more miles per gallon, okay? So that's about as good as I can make this plot. So let's move up the list and move on to area. So we can take this same data and represent it with bigger or smaller area, like this, for example. So here, bigger area means more miles per gallon. And I've also ordered them just like the trend that we had in the colors, but they're ordered by their miles per gallon. So I can tell, of course, that the Toyota Corolla beats the Lincoln, for example, here. Now, this kind of plot might seem a bit odd, and indeed it is, but we actually use them all the time. For example, in a bubble plot like this one, where again, the area of the points here, the plotting character, is used to display, in this case, a third numeric value along with the x and the y that we're showing with the traditional axis that we have here. Okay, let's move up. How about slope? So, well, here I'm displaying the same miles per gallon data set using a different slope for these lines. But the highest miles per gallon is a straight vertical line here, that's the Toyota Corolla, and then the slope changes as the miles per gallon decreases in this case. So again, I can see these sorts of differences quite easily, but for finer grain differences here, it's getting still kind of challenging to see them apart. Now again, we use this type of display of information all the time. For example, in traditional line plots like this one. So this data here, it's taken from The Economist magazine, a traditionally excellent source of good data visualizations. And this was from an article that was concerned with population growth and the exhaustion of natural resources in certain areas and regions around the world, like fresh water, etc. Now, they were actually discussing population growth, and all the slopes were increasing. If I go back to that plot, that things are increasing, that there is a population growth. But what we were actually interested in here was the slope. It is the growth. So why not plot that directly in this case? Plot the gradient of that line directly. So there's the traditional one, and if I change it, go from their data, which they all make available, which is very nice, so we can replot it and plot it as the slope, we'd see that things are actually very different. It's a different story. In fact, in all regions of the world, including in Africa, from more recent times, population is not growing at an increasing rate. It is in fact the opposite. It's decreasing. Folks are having smaller families everywhere than they used to have. And the story is perhaps rather different here. And what things determine these blips? These are the more interesting things to talk about here, this change in these trends. So let's move on for a moment and talk about one of the more controversial aspects here, or aesthetics angle. Now, the observation here, and this comes from the work of many people, is that pie charts, that's where we use angle most commonly, are nearly always a mistake. Unless you have only a few categories of things that you're trying to compare, and you don't really care about comparing the precise values, the precise differences. So this is a quote from Edward Tufte from one of his blogs, and he says that pie charts here, I'll let you read the rest for yourself, but pie charts are the information visualization equivalent of a roofing hammer to the frontal lobe, right? And in case there was any doubt about how he feels, he goes on to say here, disparage them further, to say they're not very professional, as you can read. So he's talking about things like this, that I completely agree. This is an abomination. Right? This comes from here when I took some data and I just put it into the numbers program that's on a Mac. It's the equivalent of Excel, and click the pie chart icon. And this is horrible. What are you meant to get from this apart from there are two big segments and I don't really know which ones they are? It's an abomination, right? Don't do this. Or something like this. This was on the news just last week. This is from ABC. And, this is a pie chart. Look at the numbers and the angles. Do they make sense? Well, no, of course not. Can you imagine what Edward Tufte would say about this? It would be pretty expletive-laden digestion of this kind of plot. So even for places that usually do a good job of data visualization, we can see things like this. This is from Politico, where we're looking at presidential debate performance and polling registered Republican and Democrats about who they think performed best in the first debate of that last election campaign. So here, amongst Republicans, the majority thought that Hillary Clinton did best, but the angles don't quite look right to me. It's only a 3% difference. And of course, among Democrats, there's a clear preference for Hillary, because they're seeing. But if we return to guidance from Edward Tufte here, we note that a table is nearly always better than a pie chart for small data sets like this, and that pie charts should really never be used. So if we go back here, and tables are preferable to graphics, as Tufte says here, for these kind of small data sets, and we display it as a table, it's going to do much better job, right? For much less real estate. We can clearly see the trend. Your readers are smart enough to figure this out, these sorts of differences. Now, of course, there are some good pie charts. This is one of my favorites. It's a pyramid on a beautiful sunny day, as you can see, and it's pretty nice. Okay, so let's move on and start to finish up here. Next, we have position on identical but non-aligned scales. What does this mean? Well, here is our display of miles per gallon for those automobiles again. And this is a somewhat contrived display, as the axes here are not aligned. So it's the width or the length of the bars that we're looking at, and we should be comparing to the scale bar here for reference. But we actually do this kind of display all the time. Notorious for this are stacked bar charts. And we can only really say things about the first category here, the purple category in this case, because all the other categories, all those other bars, the different colors, they're on different unaligned scales. And so the point here is, that stacking anything is nearly always a mistake. It would be much better to show this data like this, like a plot, like the one I have here. Now we can see on aligned scales, on aligned axes, we can compare these different categories and compare within them and indeed between them. So what we've arrived at now, finally, at the top of our aesthetic ranking list, is position along aligned or common scales, such as this x-axis here. Now, we can actually take this plot and make it a little bit better, because the bars here, they really capture the eye of the viewer and draw it in. We really want our viewers to focus not on the bars itself, and sometimes this strange kind of like diffraction pattern like effect we'll get with all the stacked bars here, but really focus on the end of the bars. That is actually the data point the data point at the end of the bar here. So we can do this with a dot plot often named after Bill Cleveland, who really brought these plots to the fore. And no, we're not finished just yet. That really helps us to focus in on the data itself. So what we've got here is we've arrived at the top of this list, and I think we'll start to finish here as we're getting interrupted. And we're going to make use of the highest ranked entry, namely position along a common scale here for all these plots. Now, of course, a side note here is that all the things that we've learned so far, like the alphabetical ordering of our data, that's a mistake, and it'll make things harder to interpret. They still hold. We still here order them by the trend to bring out this pattern. So we're ordering by miles per gallon rather than the default alphabetical ordering that we often get with these data sets and these plotting functions. So now, for the first time here, we can see differences where we couldn't before. For example, between this Maserati and this Chrysler. And you know, get the Maserati because your mechanic will love you, right? More seriously, you know, the observation here is that comparison is trivial on common scales. So we're going to finish up here because of the interruptions, and we're going to, in our next video, we'll delve into actually the fun stuff and learn how to make informative and compelling figures in R with the ggplot2 package and others. So please join me then. Thanks for watching.